Today is 10 days away from my next marathon race. That is why I am rushing to complete my monitoring of Apache NuttX continuous integration, or NuttX CI. Today we shall talk about a new program that I wrote, a new script that will download and pass the GitHub build logs for NuttX. Why are we doing this? We spoke about monitoring our NuttX continuous integration, like the utilization of our GitHub runners. During these peak periods where we notice very high utilization of GitHub runners, we need a way to monitor and find out what exactly is taking up all the utilization of GitHub runners. Why are our GitHub jobs taking so long to run? That is why in the last video we spoke about this PR monitor. We need to have a web page, a real-time monitor screen that will show all our PRs, how many builds they have gone through so far, and any errors that they've encountered. Now, to do this, we need to implement some kind of parsing of the GitHub build logs. Otherwise, we won't be able to figure out whether it's an error or warning or whether the build was successful. That's why today we'll talk about parse NuttX builds. This is the script or the Rust program that I wrote that will parse the build logs for NuttX after downloading them from GitHub. Let me draw a picture to understand, to show you how it works. Here is our new program that I'm presenting today. It's called Parse NuttX builds. What Parse NuttX builds will do is that it will take the data from GitHub. So it will fetch the build logs from GitHub. It will do this by calling the GitHub API. In a while, I'll show you the scripts for doing that. Okay, sorry, my screen's a bit blurry right now. Now, what is the output from this script? Parse build logs, parse NuttX builds. Parse NuttX builds will output the log in a JSON-friendly way. It will output into 3 folders. The 3 folders are success, warning, and failure. In a while, I'll show them. The idea is that we have one folder. They will record all builds that have succeeded. We have another folder that will record any warning messages, and another folder to record all, not failure, but error. ERROR. Yeah. We have 3 folders, one to record all the successful builds, another folder to record all the warnings, and one more to record our errors. Why are we breaking into 3 folders? This is for ease of processing by later tools. There will be 2 other tools I'll talk about in a while. This is part of a pipeline for processing the GitHub jobs that have run in NuttX, so that at any point in time, we can look at the dashboard and figure out which builds in NuttX CI have succeeded, which builds are giving warnings, and which builds are giving errors. Let me talk about first what's inside these folders. These folders are checked into the GitHub repo, and the name of the repo is NuttX GitHub jobs. Here's the name of the repo. So what I mean is that these things actually belong to this particular repo here. Let me show you these 3 folders. If we go into the NuttX GitHub jobs repo over here, I explained this in an earlier video. Today we have extended it to include more information. Inside NuttX GitHub jobs, we see the 3 folders: success, warning, and error. The error is more interesting. Let's go in there and take a look. These are the run IDs or the job IDs. Every single GitHub Actions job that runs will be assigned a run ID or job ID. These are the IDs that we will get from calling the GitHub API. Let's browse into one of them. Let's say this one. Now, inside this folder, we will see the errors that have been passed and dumped up into this folder here. We will see 3 errors, or at least what my script interprets as an error. Now, have to remember that in NuttX build logs, it's not exactly clear whether something is an error or warning or successful. Let me show you an example. So if you go back to NuttX, let's look at the actions. Let's pick any job under build. Let's say this job here. If you look at the steps, let's say ARM01. The difficulty we have today is that we need to be able to pass this kind of logs. You should have seen this, you should be quite familiar with this, but notice that it doesn't really tell you whether it was successful or failed. You have to watch out for keywords. In a while, we'll run through the logic for passing these logs. We have to extract things like the configuration. So we call this the bot/config. We have to ignore these messages. We expect that every single build log will have messages like cleaning, configuring, disabling, building, and so on. These are normal messages that we should ignore, and our script does that. What's left is that we do a reverse filtering. We look for these messages. Any of these messages are not expected. Those are the warnings and the errors. If we go back to our error folder just now, we see that there are 3 errors. Notice that the format that we use is that it's something colon something colon something. The first thing in front is the CI job. For example, we have ARM01 to 15 and RIS501 to 06. The next part of the file name is the bot. revert is the bot, which is QEMU for RIS5, followed by the config. So this is the config file. Sometimes you call this a target also. revert red64 Rust is the target for NuttX. And all this resides in a folder which is indexed by the run ID or the job ID in GitHub. Let's go into the JSON to see what's happening. This is the output from our parsing. We will see that yes, we have the timestamp, we have the architecture, sub-architecture, the group, the bot, and the config name. Build score is 0 because it's interpreted as a failure. The build score ranges between 0 to 1. It's a floating point number. 0 is failure, 1 is successful. Anything in between is a warning. Sometimes we use numbers like 0.8 to indicate a warning. Here is the message that our script has detected. Failed to connect to job server from environment variable, so on and so forth. Now, this is not exactly an error. Even though it says warning, our script doesn't trust the message coming up. Some of these can be quite serious. But in this case here, failed to connect to job server, it really sounds like a common warning. What we might do is that later on we'll change our script to ignore these kind of messages. So how it works is that we'll look out for this message, fail to connect to job server for environment variable. If we see this message in there, we'll simply strip it off. That way we exclude this as a warning, and this will appear as a successful build. Inside here is a helpful feature, a link to a URL. Let's go in there and take a look. If we open this, we will see a direct link to the job. Yeah, here you go. This is highly useful. Later on, when we are building our new dashboard, our new PR monitor screen, we will have this URL hyperlink to this error. There'll be an error message, and it will, when you click on it, it will jump to the error. That's why having the URL is super important. We have seen errors. Well, that's not really an error, but let's take a look at the real error. If we go back to the folder here, you see something called extensor, so on and so forth. Now, this is a real error. This is coming from the extensor build, ESP32 build, and we can see that it's a real message. Our script has helpfully extracted the actual error message from here, and this will be displayed on our dashboard. And then when we click on this, it will jump to the error message in the build log. Let's go in there and take a look what it looks like. It will look like this. Here you go. Which means that our tool is now becoming already helpful. Instead of going through manually to filter out all the logs and then scrolling up and up and up to figure out what happened, our tool is now able to extract all these error messages and dump it out. It does a pretty good job. It has identified a few errors and warnings. It seems to be pretty intelligent. It's just that it's extracting a bit too much. Some of these things, like failed to connect to job server, it's not really an error, but it thinks it's an error, which we need to fine tune. And these kind of things, this kind of fine tuning will happen during the course of the year as we maintain this tool. There'll be more kinds of warnings that we have to ignore. Now, why did we treat this as an error? Job server issues might not be always due to error. For example, if we do a search, let's say, let's go back up here, and we do a search for job server. There have been some cases where job servers will trigger an error that needs to be corrected. For example, we see here. This means that in the past, we actually had issues with the job server for this build specifically, MSys2, which is for Windows. Yeah, so sometimes it's good to highlight these things so that we need to fix them in the build. What does a job server mean? Frankly, honestly, I am not quite clear what job server is doing here, but I have an idea that this is coming from the make command. Make command is doing a concurrent builds, a parallel builds using multiple processes. For some reason, this build script is not able to access the job server inside the make tool. And I assume that the job server is a part of the make tool that will monitor concurrent builds, and somehow that's not working. Sometimes it's good to flag out job server errors so that we can fix them correctly, like this, right? But if it happens too often, it's kind of annoying. Therefore, in this particular case, failed to connect to job server, I will probably disable this message because it's not really helpful. It might be something that we need to look at. It's very strange that it's happening only to Rust programs. So we have two programs, two targets based on Rust. We have a RISC-V Rust target for LEDs. We have a SIM3 target for Rust. Only these two targets are showing job server errors. So something interesting that we need to look at. We have seen the error folder. Now let's go into the warnings folder. So warnings, we will see more things, I suppose. Let's go and take a look. Let's see this message. Now, this is interesting. Why is this considered a warning? Let's go in and take a look at the actual build log that triggered this warning. Remember that the logic that we use is that we will filter out all the known messages. Anything that's unknown, we will flag out as a warning. Well, the problem is that we can see that the message here is mangled. it's not quite what we expect. It's complaining about this line called time current. Yeah, so unfortunately, we're not able to apply a standard pattern. These lines were mangled, and I believe it's coming from the curl command. The curl command does an auto refresh kind of thing. It will print out one line, then it will go backtrack, and then it will replace the line again and again, which means that some of these messages are corrupted. Well, these messages don't have a fixed pattern now because they look strange. They look different every time it runs. Therefore, we are not able to apply a consistent pattern to remove these messages. So maybe we'll do something really tricky, like for example, I'll compress it, I'll remove all the spaces so that it will appear as time current deload upload. Then if I see that this is happening, if I see that these messages are appearing without the spaces, then I would ignore them. Yeah. However, there's still a chance that they get corrupted. So you can see here that some of the fields are totally mangled. I'm not able to understand what they are. These are also totally mangled. So there's still a chance that our pattern will fail. But we'll try our best. These are things that we'll try to fix in our pattern matching, and I will show you the patterns in a while. Other kinds of warnings, let's go and take a look. So these are really warnings that we can probably ignore. So that, for example, this is something that we could filter out. This is something that looks common, and we probably shouldn't flag this out as a warning. So we will tweak our patterns to filter out these messages. If we go back again to this target here. Okay, this is interesting. Yeah, so this is a problem with the config file. Let's take a look. So yes, this is very helpful. It has filtered out a error, in fact. This is an error that happens in a dev config file. If we don't do a dev config correctly, it will show this kind of messages. Unfortunately, our tool has flagged it as a warning, not an error. This is really an error. It will stop the build. As we can see, our parsing tool is doing a good job. It is watching out for these errors, but sometimes it's not quite consistent. It will flag errors as warnings. Sometimes it will flag warnings as errors. And you can see how difficult our job is. There is no indication here this is a warning. There's no keyword warning, or there's no keyword for error. However, it's because of the rules, because of our manual inspection, because we filtered out all the normal messages, then we realize that this thing here is actually quite serious. It's probably a warning or an error. But there is no clear sign whether this is an error or warning. That's why, well, too bad our tool flagged it out as a warning. Yeah, so it's a bit tricky. We have to flag out all these things. Maybe through time we will be able to figure out if this is a real warning or a real error, or maybe we need to fix the build script. But at this point right now, this is the best that we can do. We can highlight that there's something abnormal here. This thing is not something that we expect, therefore we're flagging out. Our script thinks it's a warning, but actually it's an error. In any case, when we render out our dashboard, we will show both warnings and errors. So it's up to a human to interpret and understand, is this really a warning or an error? Well, so anyway, we'll show everything so that it's easier for us to troubleshoot any errors in NuttX CI. Heading back, yeah, so that's the warning folder, which is super helpful because sometimes it has errors in there. The last folder we'll look at is success folder. Success folder is a long list of all the builds that have completed successfully. So we will see a long list of targets. If you ever want to figure out if a particular target is successful, well, come to this folder here. So it's going to be a long list, but let's take a look. Since it's a successful build, we will not have a message. It will not say any warnings or any errors, so there'll be nothing in there. But there's a reference to the build log. In case we need to render this, we can still do that, and we can hyperlink it to the build log that generated this. Yeah, you can see that. Yeah. Unfortunately, what could be really helpful is that if we could maybe flag out these things, like the job was cancelled. Right now, our tool doesn't do that. But it would be helpful if we can see that sometimes a build was cancelled and we should be able to filter out this message so that we can know what happened to this build and that it didn't succeed. But that's for future expansion. Right, there's a lot of discussion about the NuttX build logs and the output that we generate. Let's talk about how this works behind the scenes. Now we look into the source code to figure out how it's doing the downloading and parsing of the GitHub build logs. Just for context, we are now here in Parse NuttX builds. Earlier on, we looked at the folders for success, warning, and error messages that were actually coming in. They actually are located in the NuttX GitHub jobs repo. We put all the data here because it's convenient, but actually they are created by our NuttX Parse NuttX builds tool. This tool will download the build logs from GitHub by calling GitHub API, and then it will generate these 3 folders. Let us find out how. The way we run this is just clone this repo and just run a script called download GitHub logs, pass it the repo owner, the repo name, and the run ID. How will we get the run ID? Well, it comes from another script. We'll cover that in a while. What's inside this script here? Download GitHub logs. Let's go in there. Here. Download GitHub logs will download the build log from NuttX, from GitHub, given a specific run ID. If we look, okay, all the way down, the logic begins here. Dump repo. Okay, dump repo will now, okay, I believe my logic is a bit wrong. There's extra stuff inside there that's not happening. Yeah, there you go, exit. So don't ignore the stuff after the exit. After exit, we're not being used. But the main logic actually happens here, right? Here is where we call the GitHub API to download the run logs, the build logs. We need to provide the repo owner, the repo name, as well as the run ID. Passing in this curl command to the GitHub API will download a zip file that contains all the build logs. This is where we unzip the downloaded build logs. Inside the zip file, we have a whole bunch of logs, which is why we have this loop here to iterate through all the jobs and to ingest them. Let's go into this ingest log. Ingest log is up here. There you go. Ingest logs will take a specific log and it will run our Rust program to pass the log. Now, there is a funny step here. For our discussion so far, we kind of made it a bit casual about the name, run ID, and job ID. We say that this is a reference to the ID of the job that's run in GitHub Actions. Well, in GitHub Actions, there's actually a very specific reason for calling it a job ID or run ID. Now, let me explain why. Under GitHub Actions, run ID indexes a specific run of a GitHub action. When we talk about doing this, we go into GitHub Actions and we do a build and we look into this. Now this number you see on top here, the 23712, so on and so forth, this is the run ID. We are running the build job using this ID. However, within that run ID, there will be a few sub-jobs. ARM01 is in GitHub Actions terminology, this is technically a GitHub Actions job, right? So to recap again, this is a GitHub Actions run that has a run ID, and this is a GitHub Actions job that has a job ID here, which is why our logic looks a bit complicated. We have the run ID, yes, but now we need to figure out what is the job ID. We need the job ID because if we want to hyperlink to a specific line, suppose we are going to index, we're going to pass this build log, and we want to create a hyperlink to this particular config. Well, this hyperlink has got the run ID and the job ID. We need both. Right now, we only have the run ID, and to get a job ID, we need to do this call to GitHub Actions, to GitHub API, so that we can select the job, let's say ARM01, and this will tell us the job ID. That's the output from this script here. Right. Good. Now that we have the run ID and job ID, we can continue. Here is the part where it runs our Rust program, cargo run, passing all this information, the repo the repo owner, the repo name, the run ID, job ID, and so on, right? Yeah, and this is the part that will generate the files in the three folders: the success, the warning, and the error. Now we dive into the Rust script. The Rust script is here. How does the Rust script pass the downloaded build log, and how does it generate the three folders? Well, here is the file, main.rs. We got this from NuttX dashboard. NuttX dashboard was a tool that we created last year that will look at the build logs coming from NuttX mirror repo and the NuttX build farm. We look at these logs and then we highlight any errors and we show it in NuttX dashboard. Today we are doing it differently. We are passing the logs, yes, but now we are dumping the logs in a parsed JSON format into three folders so that they can be used by a subsequent tool. If you look at the source code, it's going to look very similar to the tool that we use for NuttX dashboard. NuttX dashboard, we call it ingest build logs or something, or ingest NuttX builds. Well, now we call it parse NuttX builds with additional functionality. Let's see, anything interesting here. So we can see that this function is now processing a file that was downloaded from GitHub Actions via the GitHub API, and this is how we process the log file. As I mentioned earlier on, we expect our log file to look like this. There's this pattern in there, configuration/tool, and there are some messages that will appear very often: cleaning, configuring, building NuttX, and so on. These are the messages that we want to ignore. In a while, we'll see the patterns that will disregard these messages in the logs. We will do some splitting based on the equal signs and headers, and then we go into the processing of targets. This is how we process one specific target. Let's say this target here. What we'll do is that, here you go. Remember we said that we do a reverse matching. To identify errors and warnings, we will filter out the known lines. And these are known lines. We watch out for things with dashes. We watch out for cleaning, configuring, selecting, disabling. If we see these patterns, we will ignore them. Right? Remember we talked about the downloading? So sometimes it get mangled. We try our best to fix it, but it's not always perfect. We can go through this file, but you can see that there are lots and lots of messages that we are ignoring, and these are the patterns that we're using. Most of this code comes from the NuttX dashboard. And now here comes the new stuff. We added a lot of new stuff, specifically for our new CI dashboard that will point out any build warnings and errors. We will watch out for these messages like hate detach, no changes to commit. We will watch out for download messages. We see lots of these messages like GCC errors, linker warnings, and all that. Let's skip them. We're not interested in them. We see problems with OBJ copy. We see problems with LTO wrapper. We will skip them also. These are warnings that we will ignore. They look okay to me. Therefore, I'm just going to skip them. And we'll add some more that we've seen earlier on. Use legacy pin map appears quite often for our STM32 targets, so let's take them out because it's not quite useful to see them in our dashboard. Although we should really fix this. Either we deprecate and generate an error, or fix it. It's a bit weird to see this all the time. SQLite target has some TCL tickle configuration problem. Let's just ignore them. Now, NTFC. So NTFC is a new framework that we're using to run CI builds in NuttX. Again, problem with NTFC is that it generates a lot of messages, but there's no specific pattern. So therefore, we have to watch out for all these kind of messages and disregard them. Yeah, that's not very robust. It's probably going to break in future, but that's the best we can do. We have to watch out for these messages and ignore them. Otherwise, we'll see lots of NTFC errors in the log. Someday, we need to figure out how to ignore these messages in a proper way, but that's what we're doing for now. It's a bit tedious, but we will do it, right? Otherwise, it will never happen. And yeah, there are lots and lots of messages in NTFC. This is a special case. QEMU ARM v AXH demo has got these very special messages. We're not sure why this is happening, but let's ignore them. These are not very useful warnings to highlight. There you go. We have lots of messages that we are ignoring. We will maintain this list to ignore all more messages. Any messages that do not match these patterns, we will interpret as errors and warnings. But then it becomes a bit fuzzy later on. What exactly is an error? What exactly is a warning? The logic is a bit fuzzy. We are not quite clear how to distinguish them, but we'll try. Let's see. There are some things that we need to ignore because these things are not errors. Even though it says error, but it's part of the file name, so therefore it's not error, right? That's how we try to flag out whether this is an error or warning. It's not foolproof, but we do our best. Let's see. And this is our score. We use 0 to indicate error, 1 to indicate successful, but then we have 0.8 or 0.5 for errors. Most of the time it's 0.8. 0.5 is if the message actually contains the word warning, which is quite rare. Let's see. And this is where we have completed our parsing. We are now going to push it out to the next step. In the future, we may push it out to a Prometheus push gateway once we are building a proper dashboard. For today, we are just writing it to a JSON file that we saw earlier on. We have the folders for success, warning, error, JSON. We are simply dumping the JSON there. And there's some logic in there that will do that. Yeah, there. This is the template that we're using to generate the JSON file. We saw earlier on there's a timestamp, arc, subarc, and so on. There is a part here for the messages. The messages will only appear if this is a warning or error. If it's successful, there will be no messages. We do a truncate here, so we do not show the whole thing. So if we want to render this thing in a dashboard, it's fine. We only limit to 512 characters. We have a limitation of Prometheus. We cannot handle long errors anyway. So we do truncate to 512 characters. And this goes into a file that we are writing. And this will go into either the successful, warning, or error folder. In future, when we have Prometheus coming up for a proper dashboard, we will send this to a Prometheus server using a HTTP post method. For now, we commented it out. We are just using the JSON file, which we can do lots of interesting things. And the rest of the logic came from the earlier code for the NuttX dashboard. And this is how we do the parsing, really. It's a lot of code in there. The main thing to watch out for are these patterns. We will need to update these patterns as time progresses. We will have to add new patterns to ignore messages. So the workflow that you expect in future, if we see a particular warning message appearing too often in our dashboard and we think that it should be ignored, we will simply add a pattern in here to skip the message. And we have to be very careful, because if we don't do this carefully, there's a chance that we may skip an actual error message. So we have to be careful in a way that we we phrase the pattern. You can see here that we try to match as much of the text as possible, but then we cannot match the whole line because some of the stuff behind can change. That's why we do not do a normalized lin num and so on, because lin num part will change. In fact, we only match the first part here. And then there are some things that we do strange tricks. Like for example, we remove all the spaces and then we see whether we have a total. And it's not TOTAL, it's a TOTA, because sometimes the L gets garbled and this thing gets treated as error message. Yeah, it's not perfect, but we'll do our best. And it seems to be picking up most of the legit warning messages and legit error messages so far. I think this code is doing so well, but once we have a dashboard, we'll see the outcome. Yeah, and that is our discussion for past NuttX builds. We have seen how our NuttX builds, we call this script called download GitHub logs, which will download the logs, the build logs from GitHub by calling this GitHub API. And then we will call our Rust program to pass the log file. And our Rust program is here under src min.rs. And this is the code that we saw that has all the processing and has all the funny patterns. At the end of this, we will write this into a JSON file that is located in 3 folders. We have either the success, warning, or error folder. And we use this pattern for the JSON files. We always use group, which is like arm01, colon board, like arm, like this guy here, and config httpd. Right, and this is how past NuttX builds work. We have just seen past NuttX builds, which will take the build logs from GitHub, download it using GitHub API, and then it will run a Rust program to generate the 3 folders: success, warning, and error, containing the success with JSON, warning JSON, and error JSON. Now let's look into the bigger picture. How are we using these files to do our dashboard? Remember that ultimately we want to have some kind of a dashboard that tells us all the PRs and the warnings and errors that are happening to these PRs. We're almost there. Let's talk about the next step. We have a NuttX build GitHub job script here. We talked about this in one of our earlier videos. We originally created this to dump out 3 folders. The 3 folders are jobs, PR, and duration. In a while I'll show them, but let me explain. Why do we need these 3 folders? NuttX GitHub jobs will dump out all the jobs that have been run in NuttX. In fact, we dumped out like all the GitHub jobs for the past year, past 12 months, 365 days to be exact. Yeah, and remember that this job is a different terminology in GitHub Actions. In GitHub Actions, they will call this a run. We will call this a job, right? Because in GitHub Actions, there will be a run that has got sub-jobs that are called jobs. So our job is equivalent to a GitHub Actions run. The job information is not meaningful without context. That's why we also dump out the PRs. We have the PRs for the past year, and we do a matching between these two. We match these two by the name to give us the PR for a particular job. And we also dump out the duration. This is a different API call. So we call a different API to dump out the duration of that job in GitHub Actions, meaning what is the elapsed time for this particular job. We were doing some analysis on the most expensive PRs in NuttX. That's why this thing is important. And then again, we will do a matching between this and this, so that we know for a particular job in GitHub Actions how long it took. Now, there's a lot of matching going on. What do we do with all this output? we will generate two files. We have a TSV file and we have a JSON file. This is the output of the matching. In a while, we'll show you the TSV file and JSON file. TSV file is the tab separated value. It is simply one row for the headers, followed by all the rows. Every single row is a job. I'll show you in a while. Then we have the data also in JSON format, meaning that we'll do a matching. Then we have a huge JSON array. Inside each JSON, we have inside each array element in the JSON, we have one JSON object that has got the job, PR, and duration merged together into one JSON object. Let's look at these things that we generated. These are things that we created earlier on and that I explained in an earlier video. Please refer to that video. What we added today is a JSON format. JSON is useful for future processing. In a while, I'll explain what we do with the JSON file. TSV is useful for manual analysis. We use this to analyze the most expensive PRs. So dumping out into TSV was very, very important. That's how we were able to identify the most expensive PRs in NuttX. Let's go into this just to refresh your memory on what it looked like. Inside the GitHub, NuttX GitHub jobs repo, we will see these folders. Actually, it's the same repo that we saw earlier on. We saw success, warning, and error. Now we look at the earlier folders. We have a folder for job. These are all the jobs that have been run in GitHub Actions for NuttX over the past year. If we just click into one of this JSON, this is the data that was dumped out by calling the GitHub API. So we will see that we'll see the title, we will see the build status, we will see when it was started, and we will see the URL that links to the GitHub Actions. But we do not see the PR information. All we can see is the title here. To get the PR information, we need to match against the PR folder. Let's go up here. The PR folder is here. And when we go into one of these PRs, let's say this one, the index is the PR number. And we'll see all the details. We'll see who created the PR. We'll see how many files were added, how many files are modified. We even see all the individual file names. If anybody wants to do some interesting analysis on this, this tells us that there were 6 lines added and 8 lines deleted. We will see the labels, whether this is a size small and this is an extensor board for the PR. Any merge information. Yeah, and this is the important part. We see a URL for the PR, so we can hyperlink to it. Now, this is important. We see the title here. This is the title that we use to match with the jobs. We saw earlier on that jobs JSON has got a title. We'll do this matching. It's not perfect, but it will do for now. Once we do the matching, we'll get the PR number, we get a PR URL, and this is what we do for our PR dashboard. We need this information. We need to figure out all the jobs and the associated PRs, and this is how we match them. The last folder we'll look at is the duration folder. Remember that this is the elapsed duration of every job. This is the run ID. The index is the run ID of that job in GitHub Actions. This is the duration in milliseconds. 28,000 milliseconds means that this job took 28 seconds. This is the elapsed time. We are talking about 28 elapsed seconds to complete this job. Now we have 3 folders. We have the duration, we have the PR, we have the job. It's a bit cumbersome to keep matching them all the time, and it gets quite long because we captured the past 365 days. What we do now is that we run a script, we run a program. The program is inside here under src main rs. This is a program that will read the jobs, the PRs, and duration. It will match them together, and it will output the TSV. It will output the TSV, and it will output the JSON. Let's take a look. Shouldn't have closed that. Let's just call it back. So what we have seen was called NuttX GitHub jobs. Right, heading back to the folder that we just closed. This will generate the JSON file and the TSP file here. There's a TSP file that's here. That's a bit too big to view right now. But if we look at our spreadsheet that we have been doing our analysis, we can see it here. The TSP file is a tab separated value that is easy to import into GitHub Sheets, Google Sheets for analysis. It just contains one row of headers followed by one single row per job. These are all the jobs that are run in GitHub Actions. You will see that multiple jobs will be linked to the same PR. Like these. These are the PR fields. We can see that these are PR title, PR number, and so on. And yeah, why is that happening? Because one PR can trigger multiple jobs, right? And that is the format of the TSP file we're looking at. The JSON file is the equivalent of that TSP file, but it's just bigger. Instead of having a header plus a data in column, we just dump it up in JSON format, which is quite huge, as you can imagine. We have job, we have PR, and we have the duration in here somewhere, duration, all matched up. And one JSON object corresponds to one single job that has been linked to its associated PR. And we do this again and again for every single job. And yes, there's a lot of duplication in there because one PR can trigger off multiple jobs. It's going to be quite long, but it's very useful for tools to process this. If we have a tool after this, which we have, and I'll explain in a while, and we want to figure out, given a specific job ID, which PR triggered this job ID, we can look up this JSON file. It's going to be a huge JSON file, but there are fast ways to process this. I'll explain why. And we look up this database ID, and we will get all the PR information. And this is a lot of data. We collected the data for the past year, 365 days. So if you're interested in the job ID for any particular job in the past 12 months, you can simply look up this file, and then it will tell you which PR generated this particular job. This is quite helpful, I think. In future, you want to figure out why certain jobs fail. We have the errors with the warnings. We can look it up, and based on a job ID, we can figure out which PR triggered this job. And this is helpful. Oh, and in our last video also, we mentioned that our job build logs will tend to expire. GitHub will expire there after 3 months. The good news is that we now have a tool that will pass the build logs, dump out into the success, error, warning, and folder. And we have a record here. Everything is checked into GitHub. We have the 3 folders in here. And 1 year later, if we need to figure out why it failed, yes, we have the record here. We have filtered all the unnecessary messages, and we now know what are the errors and what were the warnings that were triggered by that job. So this JSON file is huge. It's 51 megs, but it's super useful. And in a while, I'll explain how we parse this. We don't have to load this whole thing into memory to parse this because it's very memory intensive, but there are tools for doing better way of processing this. There. That's all I have to say about this particular tool that we created, NuttX built GitHub jobs. In the past, we used it to dump out the jobs, the PRs, and duration, and we mashed it up to create a TSP. Today, we added in a new addition, JSON. Now we have a JSON version of this file, which will be useful for other tools. What other tools? Let me show it to you. Why are we creating all this information? That's because we are now creating a new tool that will render our PR status dashboard. The new tool that we are creating is called Export NuttX Builds. All this information we have created in JSON format. This is all in JSON, and we have also this JSON here. Well, we will simply ingest all this helpful JSON files, and we will create something meaningful out of it. What will we create? We will create a static HTML that will render our job status, our PR status. Any errors, any warnings, it will appear in this static HTML. Let me show you a sneak peek. We're still doing this right now. It's got a lot of logic in there, as you can expect. It's merging a lot of data sources. And we are now building this part here. And in fact, I'm having trouble sleeping because I'm trying to build this before I fly off in 10 days. But it will look a bit like this. The idea is that this is a preview. We will have a timestamp. We have PR. We will have a PR title followed by the error and warning. This is a static HTML. Earlier on, we said that there will be a nicer dashboard, Grafana, based on Grafana and Prometheus. We'll keep that for future. For now, I've got 10 days to come up with this static page. It's not auto-refreshing, but then we have the browser extensions that will do an auto-refresh. So that's good enough. We will simply dump out a static HTML and publish it to GitHub pages, github.io, that will have every single PR. It will tell you if there were any errors and warnings for PR, which is quite useful. Remember that today we have to scan through all the logs to figure out, if there are any errors, why it failed. Well, now we have a dashboard that will tell us exactly why it failed, because the error will be here. And there'll be a hyperlink to the PR, so we can jump straight to the PR to see what the code is like. And we have a hyperlink here to jump into our build log. That is why we went through so much trouble to parse the build logs. Now we have lots of information here, and now we can present it in a nice format here. And this will be useful if we ever hit high utilization of GitHub runners again. If we had this tool in January and February 2026, we would definitely run it to see what was happening in our GitHub actions. In the past few videos, we found that a lot of this usage of GitHub runners was wasted on downloads that failed. At the time in January and February, we had no tool to figure out what was failing. And now that we're looking back at the logs, we realized that a lot of downloads were failing when they shouldn't have been, which is why we have this tool now, which will be very useful. It will flag out any problems like download errors. And that's why we are also now building new things, new mechanisms to do like a CI build retry. If a download fails, we will retry. The other reason for building that dashboard is that we are now rolling out new tools. We have rolled out NTFC tools. Actually, we rolled it out in January, around the peak period. We have just rolled out an enhancement to NTFC that will have fewer errors. It uses the pip Python package manager. And we are about to roll out this tool. But we need to monitor these tools. We need to figure out if they are still generating errors. Having a dashboard like this will be super, super helpful because it will flag out any errors in NTFC, any download errors, any retries, right? Right now, when we are testing this tool for CI build retry, honestly, frankly speaking, I have difficulty. Every time I run this tool, I have the logic in there to do retries, but reproducing a download failure is very, very difficult. I've been running this tool for over a week. I do not see any errors in downloading. What do I do is I keep retriggering a tool again and again and again. Then I keep going in and clicking in to see all the logs, searching for any download failures, searching for any retry attempts. This is getting painful. That's why I'm also creating this dashboard to help myself. Now that it will flag out to me that any download errors, and it will flag out to me if there are any retries. Yeah. In summary, this dashboard will be super helpful because during times of high utilization, we need to monitor what are the warnings, what are the errors, so we can take action immediately. We didn't have this tool in January and February, so unfortunately, we couldn't do anything. But now that we have a tool, we can do a lot better. Second reason for rolling out this dashboard is that we have changes to NuttX CI. We have changes for NTFC, we have changes for the retry logic. We need to monitor these things when they roll out. And we need a tool to dump out any warnings, any errors, so we can monitor if our changes to NuttX CI, are they actually working correctly, right? So now we see that this thing is super, super helpful. which leads us to the next step. How are we going to generate that HTML page? What's inside this script called export NuttX builds? It's work in progress. This export NuttX builds, it's a Rust program right now. Let's hit in there and just run it. Sorry, just see the output. Right. It's going to be a lot of matching. We need to iterate through all the job IDs. Now, we have done the error and warning folders, right? We have this thing, remember our past NuttX builds, it will generate the folder for it will generate the folders for warning and error, and that's coming from our past NuttX builds. Now is the time to ingest this into our new tool, export NuttX builds, and use them. Remember that our dashboard will be concerned about errors and warnings. We are not concerned about success. We are concerned about failures and warnings, which is why export NuttX builds will iterate through the error and warning folders. We have helpfully named the subfolders by the run ID. So by looking at the error and warning folders, we will have the run ID, or what we call the job ID. Super convenient, right? Then we need to do the matching. Based on run ID, we need to do the JSON. We have JSON in a few places. We have JSON in the error and warning folder. We have JSON that we saw earlier on for the jobs, the PRs, duration, all that. That's why we need to do all this matching. So let's say we hit an error message here. The folder name for the error message will give us the run ID. We will take the run ID and match it against the JSON here. The JSON here will tell us which job this is, which PR triggered a job, and the run duration. And that's why we are all able to render all this huge join merge JSON into a static HTML. That's what this logic is trying to do here. Our dashboard will stop iterating after 5 days. We don't want to show too much data in our dashboard, so that 5 days is probably good enough. We will show the latest jobs in front, which is good. As we refresh this table, we will see new things appearing on top. And it's also good for us doing the CI monitoring. We'll just simply look at the things in front, on top, to see if anything failed. It's also good for NuttX developers. NuttX developers, once they submitted a PR, and they wonder if their PR is hitting any errors, they can watch this dashboard, do an auto refresh, watch this dashboard, and they can see in real time if their PRs are triggering errors and warnings. Why is this helpful? Well, today with our PRs in NuttX, when we submit a PR, yes, it will run the job, but then it will run the job to the end. If it hits any errors in there, you will not know until it hits the end, and then this flags the error, and then it cancels all the other jobs. With this thing, it will render in real time, right? Fantastic. It will see any errors, any warnings coming out in real time before it reaches the end of the job and before the job fails. Super helpful for NuttX developers. But there's a limiting factor. We are calling the NuttX API to fetch a lot of data, which as we saw earlier on. And the GitHub API has got a rate limit. We are not allowed to call the GitHub API too often. They will block us. That's why I inserted a lot of delays in our script. Every time we see sleep 1 second here, sleep 1 second there, we are sleeping a lot because we are trying not to hit the rate limits in GitHub API, which means there will be a limit to how often we can update this. So I'm hoping that we can do this intelligently. Let's say if we just fetch data for the past day, maybe we can complete it in 5 minutes, maybe at most 15 minutes. But again, it depends on the load. If we are experiencing very high load and we're fetching all the jobs for today, it will take longer. But let's see how that happens. The summary is this. Yes, we have a very nice dashboard here that will show us our warnings and error messages in real time. But it's close to real time because we have limitations in our GitHub API rate limiting. We cannot call the GitHub API too often. Therefore, we expect this thing to be updated every 5 minutes, 15 minutes, or maybe later. I'll put a last updated at timestamp on top so that we know that this thing is updating. And that is happening in this Rust program here, export NuttX builds. It will pull up all, given a run ID, it will read the job PR JSON that we saw earlier on, this huge JSON file, and it will look up what exactly is the job PR that triggered this run ID. Remember I said that this JSON file is a huge file, 51 megs. Normally we will read it all into memory, then we do the scanning to figure out this run ID corresponds to which PR. But there's a smarter way to do that. There's something called a streaming JSON reader, meaning that we do not load everything into memory. This JSON PR file is quite huge because we did a matching for the past 12 months. Imagine we have 365 days worth of jobs and PRs in that single JSON file. 51 meg is huge and it will grow. Therefore, not a good idea to load the whole thing into memory, but in fact, we do a streaming JSON reader. What is a streaming JSON reader? It means that our the utility that we're working here, the Rust library that we're calling, the JSON simple JSON reader, will helpfully scan through our JSON file line by line, actually chunk by chunk. It will not load the whole thing into memory, but it will just scan through line by line, which is good enough for us because all we're doing is that we're looking out for this line called database ID is equivalent to a run ID. Well, therefore, we're just simply doing a scan. If we see this thing called database ID and this database ID matches our run ID, yep, we found it. That's it. This is perfectly fine for us. We do not require too much memory. We are not loading all 51 megs of JSON into memory, but rather we are doing a streaming on the fly. So that's a very good, helpful tip. If we're doing a huge JSON file, always use a streaming JSON reader. There are cases like this where we do not need to read the whole JSON file into memory to interpret, but rather we can just simply scan through the file and look for patterns, and then we will take action based on the pattern. Imagine it's like doing a grab. When we do a grab by pattern matching, it's the same idea. We're doing a streaming JSON pattern matching here. What do we do once we have found the record number? Remember that our huge JSON file is an array of records, array of JSON objects. We need to remember which index we found it. Then we will need to do some seeking. We will jump into the index, and then we will extract the job and PR information from that huge file. There. The few lines of code here will simply look for our run ID inside our huge JSON file. It will extract the job information and the PR information. The next step is to merge our build information. Our build information we saw earlier on is like the warnings and the errors. We need to know what is the warning message, what is the error message, which are the URL pointing to the build log, and so on. This is part where it merged. Then once we are merged into this huge JSON, we will have the job information, the PR information, as well as the build information. And that is how we do once we have this huge merged JSON, we will take it back here and we will dump out into HTML. It will look a bit like this, right? We need to dump up the timestamp, the PR number, the error warning messages. It will have more columns, like, for example, the title of the PR, maybe the first X characters. And then we will generate a HTML table. The code will look like this. When we render it, it will look like this. And then, of course, we have the clickable links, right? PR will click on it, it will link to a PR. The error warning messages, click on it, will lead to the build logs. And that's it. We are now working on this part here. We are now going to merge, and then we are going to export the HTML. And we are done. We will have this nice dashboard. They will tell us in real time, near real time, what's happening in our CI builds, whether any errors and warnings are coming out. And this is it, right? So we have we have a lot of data floating around. It's a huge data processing job, data massaging job. Ultimately, the goal is that we want to generate a single huge JSON that has the job, the PR, and the build information. This is all inside one single row. Sorry, let me refresh the screen. There you go. We have one huge database of JSON for job, PR, and build. That will be the job of our export NuttX builds script, and this is what we will use to generate the static HTML. I will probably check in this JSON into the repo so that it's available publicly for access. If you find that the static HTML is too plain, too boring for you, it's not too exciting, and we need some more features, like for example, we need to do auto refreshing, we need to be able to filter by jobs and all that, well, I will leave this JSON file that merges everything together. This JSON file will be published at the public location, github.io, GitHub pages. Anybody wishing to write their own tool, go ahead. You can just download the JSON file, which will always be updated every few minutes, and use it to build your own dashboard. Right? Yeah, I've got 10 days to do this before my marathon race. I'm flying off soon. Therefore, I'm doing a simple workaround. I'm just going to generate a static HTML. It's not going to be very pretty, but it's functional. It links to the PR, it links to the build logs. But I'll leave the JSON file published publicly so that anybody who wishes to download the JSON file can do their own analysis and publishing. I mean, I can imagine if I'm a NuttX developer, I would simply download this JSON file and search for my user ID in that JSON file just to see what's happening to my PRs. Super helpful, right? You can do that because the JSON file is public. So I'll publish it somewhere and you get it from there. There. So we have a lot to do in the next 10 days before I fly off for my next marathon. Why are we doing all this work here? Again, we are doing this because we are expecting another peak period. Maybe before the next Lunar holiday, this may happen again. When this happens again for our peak period, we need to understand what exactly is causing this peak period. Are we hitting a lot of errors in our GitHub runners due to downloading errors or due to some other things that we couldn't see? Our tool here will be able to do all this matching in real time, close to real time. We will generate a dashboard for that. Another reason for building all this is that we need to monitor changes to NuttX CI. Back in January, we rolled out NTFC, but we didn't monitor it. We didn't have tools to watch out for any errors in NTFC. Now looking back, we actually discovered some errors in NTFC. It was trying to download some Ubuntu packages and it was failing, which could have contributed to this peak in January and February. If we had the tool, it will show up. It will show up the Ubuntu errors and it will flag them. But fortunately, we have a new version of the NTFC framework now. We do not use Ubuntu. We now use the pip package manager, which also means that I need to monitor the pip package manager. Are we seeing any pip errors? This thing might tell us. Yeah, there. Yeah, so a lot of work to be done for the next 10 days. I'll update you in the next video if I can before I fly off. And also, I will continue testing for our retry mechanism. The difficulty I have, like I said, is that it's very, very difficult to reproduce our download errors. I tried it one whole week. I couldn't get any download errors. So moving ahead, yes, I can probably trigger this a lot more often. Instead of going into a logs manually to click in and see myself if there were any download errors and any retries, I can now simply have this dashboard here. I can refer to this dashboard to see if there were any downloads that failed, any retries happening, which is good because it means that I can now monitor our script to see whether it's working correctly. And hopefully this thing will continue running even while I'm away from a marathon race. And after marathon, in end of April, I will have all the data here that I need to assess whether my retry script is working correctly. Yeah, there. So we day by day we are making things better with NuttX CI with lots of constraints, but we are slowly filling up the gaps. We now have a pretty sophisticated tool. It's almost like a data mining tool. We are mining through all the jobs, PRs, and build logs for the past year, and we are producing meaningful data that's really going to be very useful for NuttX CI maintainers as well as NuttX developers. I will put the links to all these articles in the video description. Thank you so much for listening and watching this video. See you in the next video.